All right, so here we are. This is the last video that I'm going to do for what is in normal years lab 2, the soldering lab. The last thing I wanted to talk to you about is how to solder something that's a through-hole component. In this case, the through-hole component in question is that we're going to solder is the connectors that you'll use to program your MSP430. And so that's a little header. And I'm going to show you how to do it here in 1 second. Let me show you my setup. This is my setup in lab. Your setup in Abercrombie or wherever the new Abercrombie will be a little bit different. Here I have a snorkel that's hopefully sucking up some sort of fumes. I also have a stereo microscope that I'm not going to use for this lab because I have instead the little USB microscopes, which I'm providing for you guys in lab if you're interested in using them. For these big components that we have for this lab, namely the pin headers, which are here, and the battery holders, which are here, and the button, which is here, you really don't need a magnifying glass at all, but it's nice to be able to use if you need to do any corrections to your surface mount soldering, like removing or adding components. Okay, so I'm going to turn off the video from my handy cam here, and then we'll just go straight to just what is being provided by our little the Zoom microphone. Okay, so first I want to show you these pin headers. They're actually meant to be broken by hand or with pliers. So in this case, what we need is we need a section of 4, so we're just going to grip them, and then they have a little groove. So if you just snap at the groove, then you'll get something that's exactly the size that you want, and that will be great. Okay, so here's a little trick that can be useful. You want your pin headers to be perfectly straight. You find a solderless breadboard lying around in lab, and you stick the pin headers into that, and then now what we can do is we can turn this over and connect to the holes that we want to solder in. In this particular case, I think I want my pins to be facing upwards. So this is now the bottom of the PCB that I'm going to solder on. You may have decided instead that you want your pins to face downwards, which would make it maybe a little bit more difficult to program, but it might make it more aesthetically pleasing. Also, if you want to, instead of using vertical pin headers, if you want to use sideways looking ones like this is the females. And then we also have the opposite connection ones that are right angle in lab as well, I believe. And that makes it maybe more like streamlined or something like that if you're actually going to use it as like a tree marker or something like that. I don't know what you guys are doing this for lab. All right. So you'll find that in lab that we have soldering iron tips that are different sizes. And a lot of times people think, oh, look, they've got these awesome, like really fine tipped soldering irons like this. You really don't need that. In fact, almost never do you need something like that. Usually you can do a lot of work with one of these big behemoths, and the difference between these is the small ones provide only a small amount of heat. So the heat, I never took thermodynamics. From what I understand, heat transfer is a lot like electricity. There's sort of resistance and there's current, and the heat is like the current, and the resistance sort of determines how fast something heats up. Or I guess the heat is more like the voltage then. So the flow of heat is like the current. How fast something's going to throw up, heat up is going to depend on like the thermal conductivity of the thing that you're connecting with. So in this case, if you have a very small tip, then you have a very small surface area, and so the rate that you can heat things is pretty small. And this little tip down on something like this that has a lot of surface area, and that's actually going to cool the tip down, and then the iron has to heat more in order to actually get heat to flow from the body of the iron into the thing that you're trying to heat. And the trick with soldering is that you want both the pad and the pin to be heated. And when both the pad and the pin are heated, then solder will flow really nicely between them. The flux that's in the solder will clean off the oxide that's on the surface, and you'll end up with like an actual chemical bond with the pad and with the pin. What you don't want to do is you don't want to just heat the pad or just heat the pin, because then what will happen is that the solder will flow and it will chemically bond to one of them, but not the other, and you'll end up with what's called a cold joint. So cold joint is when the solder is stuck to one side but not the other, and it looks like it's melted and it's in the right place, but it's actually not. And so when you're soldering, the first thing that you want to do is you want to make sure that your tip is nicely tinned. So what I'm going to do is I'm going to apply some solder to it, and then I'm going to go over here to my my sponge, which I've put some nice water on, or to my metal sponge, which looks like a big nest of brass filings, and I'm going to scrape my tip. Now my tip is nice and shiny. That means there's not an oxide coating. So oxidized metals don't conduct heat well. Their thermal conductivity is poor compared to unoxidized metals. And then what I'm going to do is I'm going to push down so that I'm actually providing a little bit of force on both the pad and the pin. So I want part of this tip to touch the pin and part of it to touch the pad. If you look at this, the tip of this iron, you see this sort of like not shiny spot right there. It's interesting. That's actually pad and part to touch the pin. And actually you want to use the side of the iron, not the point. The pointy part has very little surface area, so it's not going to heat very well. So you actually want to use the side of the iron to do your heating. So now I'm touching both parts, and then what I'm going to do is I'm just going to let the solder melt on my iron. And what you'll find is that the solder flows really nicely when everything is heated. It flows and it makes a really nice connection. So now I'm going to adjust the angle here so you can see the same process from the side, because I think that a side view may be helpful for us. Let's get our angle adjusted. So magnifying glass. All right, so now here's the side view. I'm going to do the same thing. The side, if you need a small piece of solder, you can just cut it with the iron. Okay, so now I have my iron. I'm going to bring it in here from the side. I'm going to touch the pad and the pin. And I'm going to bring my solder in. And what will happen is that there's a really nice flow that makes a little curved tint of solder. And what happens is that as the solder melts, surface tension will pull it into that really nice sort of tinted shape around the pin and into the hole. Because these holes are a little bit bigger than the size of these pins, then what's happening is that we're actually probably we're filling that hole a little bit with solder as well. Okay, so now sometimes what I do is I touch the soldering iron a little bit if it doesn't seem to be heating, and that's what that will do is it will allow the flux that's in the solder to clean off the tip of the iron and create a hot spot again that can be used to reflow the solder. So we heat the pad and the pin, and we melt, and we end up with something that has these very nice tinted shapes. All right, and everything was being held steady for us by the solderless breadboard. And now that we've got everything in, we'll unplug and then we'll look. And what we see is we see very nice connections. And you see how the solder is sort of shiny, and it's also, it fills the holes and it makes a very nice pattern. So I'm not very good at doing bad solders on purpose, or else I would do that so that you guys could see what it looks like. But when you don't have a good solder joint, then often what you'll see is something where instead of the solder being shiny, it looks sort of gray and dull. That's a sign of a bad solder joint, because it means it's sort of oxidized in the process of reflowing. And another thing that you'll find is if you get a big blob of solder on the pin, if you get lots and lots of solder and it's up here and it's not really touching the pad, then that's a sign that you heated the pin but not the pad. So the solder melted onto the pin but didn't flow into the pad. And conversely, if you see something that looks like a ring around the pin, then that means that you've melted the solder onto the pad but not onto the pin. So you really want to see that sort of curved connection onto it. All right. So hopefully this was helpful, and hopefully you guys will enjoy the process of learning